At first glance, the comparison seems absurd. A MotoGP bike produces around 300 horsepower, reaches nearly 360 km per hour, and uses carbon brakes glowing at about 800 degrees Celsius. A Dakar Rally bike makes roughly 60 horsepower and tops out near 170 km per hour. Yet if a MotoGP machine were dropped into the brutal Dakar Rally, it likely wouldn't survive even half an hour. That contrast highlights how specialized motorsport engineering has become. MotoGP bikes are built for maximum speed on smooth circuits, while Dakar machines are designed to endure thousands of kilometers of harsh terrain. Two machines built for completely different missions. A modern MotoGP bike is essentially a guided missile with wheels. These motorcycles are powered by 1000cc engines producing more than 260 horsepower, revving to nearly 19,000 revolutions per minute. They feature seamless gearboxes, advanced aerodynamic wings, and electronic systems capable of adjusting traction and engine behavior corner by corner. The KTM RC16, for example, has a minimum dry weight of about 157 kilograms, a 22-liter fuel tank, and can exceed 340 km per hour on long straights. Every component is engineered around one single question: how fast can this motorcycle go for about 45 minutes on perfect pavement? Now compare that philosophy to a Dakar Rally machine like the KTM 450 Rally. Instead of a screaming four-cylinder engine, it uses a single-cylinder 450cc engine producing around 60 to 70 horsepower. Dry weight sits roughly between 138 and 145 kilograms, but once fully fueled with 30 to 35 liters of gasoline, the bike often exceeds 170 kilograms. This machine is not designed to break lap records. It is designed to survive. Dakar stages can stretch for 500 kilometers or more, and the full rally covers around 8,000 kilometers over 2 grueling weeks. Riders must cross deserts, rocky plains, riverbeds, dunes, and unpredictable terrain while enduring extreme temperatures. In that environment, reliability matters far more than peak performance. Sprinter versus ultra-marathon runner. The easiest way to understand the difference between these machines is through a simple analogy. A MotoGP bike is a sprinter. A Dakar Rally bike is an ultra-marathon runner. MotoGP engineering pushes every component to the absolute limit because the race distance is short. If a part survives the race weekend and fails immediately afterward, engineers may consider that perfectly acceptable. Dakar machines follow the opposite philosophy. Everything must withstand hours of punishment every single day, often in remote areas where mechanical failure could leave a rider stranded hundreds of kilometers from help. Instead of chasing maximum horsepower, Dakar engineers focus on durability, reliability, and rider endurance. Why Dakar bikes carry so much weight? Looking at the specifications alone can be misleading. A MotoGP bike has a minimum dry weight of around 157 kilograms, while a Dakar bike may start lighter but becomes significantly heavier once fully equipped. So where does all that extra weight come from? Fuel capacity. Fuel is the biggest factor. A MotoGP race typically lasts around 120 kilometers, so a 22-liter tank is sufficient. But Dakar Rally stages can exceed 500 kilometers between refueling points. To handle that distance, rally bikes carry 30 to 35 liters of fuel, often split between multiple tanks positioned at the front and rear of the motorcycle. These tanks are carefully integrated into the chassis to maintain balance while still being strong enough to survive crashes and impacts with rocks. Navigation systems. Another major addition is the navigation tower. Unlike circuit racing, where every corner is known in advance, Dakar riders must follow a roadbook navigation system guiding them across the desert. Mounted in front of the handlebars is a structure containing digital trip meters, roadbook scroll systems, navigation switches, backup electronics. This tower must withstand violent shaking, crashes, and extreme vibrations. It adds both complexity and weight to the bike. Stronger frames and components. Dakar bikes also require much stronger structural components. The rear subframe, for example, must support spare parts, emergency equipment, and the rider's gear while absorbing constant impacts from rough terrain. MotoGP machines can use delicate carbon components because any failure occurs on a racetrack with mechanics nearby. In the desert, if the subframe breaks 250 kilometers from the bivouac, the rider is effectively stranded. Durability always wins over lightweight construction. Wheels and tires built for war. The wheels tell another important part of the story. Dakar bikes use 21-inch front wheels and 18-inch rear wheels. paired with heavy-duty rims and aggressive knobby tires. These wheels are built to smash into rocks, sand dunes, and ruts repeatedly at high speed. Many use mousse inserts instead of traditional tubes, preventing punctures during long stages. MotoGP bikes, on the other hand, run 17-inch forged magnesium wheels with slick racing tires optimized for maximum grip on smooth asphalt. Those slicks would be completely useless in the desert. On sand or loose gravel, they would spin uncontrollably and quickly shred against sharp rocks. Suspension. Perhaps the most dramatic difference between these motorcycles is their suspension systems. A MotoGP bike typically has about 115 millimeters of suspension travel. This setup is perfect for dealing with small bumps, curbs, and subtle changes in track surface. But Dakar bikes operate in an entirely different world. They run around 280 millimeters or more of suspension travel, designed to absorb massive impacts from dunes, jumps, and deep ruts. Take a MotoGP suspension system into the desert, and two things happen almost immediately. First, the suspension bottoms out constantly, slamming metal components together and causing damage. Second, the stiff race-tuned valving sends every bump directly into the frame and rider. Dakar suspension, by contrast, is designed to remain forgiving across a huge range of terrain. Why MotoGP brakes would fail in the desert. MotoGP motorcycles use carbon brake discs, which are incredibly powerful but require extremely high temperatures to work properly. They operate best between 300 degrees Celsius and 800 degrees Celsius. On a racetrack, repeated heavy braking from speeds above 300 km/h keeps the brakes within that ideal temperature range. In desert riding, braking conditions are completely different. Speeds are lower, traction varies constantly, and riders often rely more on engine braking and the rear brake. Carbon discs would remain too cold and would deliver poor stopping power. For that reason, Dakar bikes use steel brake discs, which are heavier but work reliably in all conditions: sand, mud, water, or dust. Electronics. Precision versus chaos. Electronics in MotoGP are incredibly advanced. Engineers program traction control, engine braking, and power delivery for specific corners on a track. The bike's electronics adjust performance lap after lap using data from sensors and GPS positioning. In Dakar racing, such precision becomes meaningless. There are no predictable corners. The terrain constantly changes. Dunes shift, rocks move, and riders may encounter unexpected drops or hidden holes. Instead of sophisticated corner-by-corner tuning, rally electronics focus on reliability and simplicity. The goal is ensuring the engine runs smoothly in extreme heat and dust, while fuel pumps and navigation systems continue working. Why Dakar bikes aren't fast on racetracks. If MotoGP technology struggles in the desert, why don't Dakar bikes dominate racetracks? Because they're built for a completely different job. A Dakar rally bike is tuned to cruise comfortably at 140 to 150 km/h across rough terrain for hours at a time. The long travel suspension that absorbs desert impacts feels unstable during high-speed track cornering. Aerodynamics are designed to protect the rider and mount navigation equipment, not generate downforce. On a racetrack, a MotoGP bike would easily outclass a Dakar machine in every measurable way: top speed, braking distance, and cornering performance. The KTM example. Few manufacturers illustrate the Dakar philosophy better than KTM. For nearly 2 decades, KTM dominated the rally with its 450 rally platform, winning numerous Dakar titles. These machines emphasize reliability above all else. They include multiple fuel pumps so riders can still reach the finish if one fails, and their engines are electronically limited to around 160 km/h for safety. That limitation might sound strange, but crashing at 200 km/h in the desert would almost certainly end a rider's race, or worse. If this breakdown changed how you see MotoGP and Dakar machines, imagine how many other racing worlds hide the same secrets of extreme specialization. The fastest machine isn't always the toughest. Sometimes survival beats speed. For more deep dives like this, make sure you like and subscribe.